Hello and welcome to our sub-series where we are going to create a very simple employee success predictor. This series is brought to you by Prairie HR Solutions. My name is Jake Finger, founder and principal consultant here at Prairie HR Solutions. And the reason why I say simple is because we're going to be doing this essentially as a prototype, and this prototype is going to have very minimal data points. Now, granted, in order to make an employee success predictor truly useful and valid, you would need, hundreds, if not thousands of data points based on each and every single employee and their tenure with your organization to include the experience and factors outside of your organization as well. So it's an awful lot of data. And because we've created a lot of videos and we are currently creating a people and culture management system, and we're doing that through Google Apps Script. Now, the reason why we chose Google Apps Script is a lot of small and medium businesses, to include a lot of large public sector businesses, agencies use Google, either the free version or Google Enterprise, or whatever, but they use Google. And using Google opens up the opportunity to use Google Apps Script. Now, Google Apps Script is a great tool if you're working with, web-based or web apps and within the Google environment, but it will have a limitation. And one of those limitations is going to be handling the mass amount of data that is needing for a machine learning tool to actually learn and model and find that probability. So there will be a point to where we're going to have to migrate Google Apps Script or this from Google Apps Script once our data becomes so robust, or we really want to drill in to the validity of it. And that will be at a later time, of course, but we would like to just get something going now, the prototype and the concept down in App Script so we can then start working with it. And the reason why this is part of that career pathing series is, you think about career pathing, it's taking an individual's current state, which essentially is the total of all their past experiences and trainings and all that. It's their past history. And then trying to figure out what is needed, essentially, very high level, to get to another level or another classification, another job or whatnot. So that's typically what it's actually been. But over the years, we realized that there's a massive piece missing from that. And that is, what is their probability of success and what can we do to increase that probability? And really, that's where that career map piece, that development map piece comes. And by and large, it's typically, from what we've seen anyway, it's largely based on an individual within HR's gut instinct to say, well, in order to get there, you could just take this class and you should have that competency or that skill, that KSAO or whatever, to be successful in that. Well, we're not really basing that on any data. We're just basing that on a whole lot of assumptions. And that's where this employee success predictor idea came from. Imagine a time when a manager or a people leader is presented with a task. We'll just call this task A. And in order to complete task A, they need a person to either lead it or work on it. Now, currently, we use our gut instinct on the data that we know. Now, if this is 1,000 lines long worth of data for one employee, we're not going to go through that. We're just going to go off of our summary, which may or may not be accurate. So if we wanted to say employee number, let's just say 6, and the task was B, imagine a time when we can press a simple button to get the probability of success based on this employee ID's past experience and what makes up that task B, what competencies, what success factors, what metrics, all that make up task B, and then find the probability that that employee is going to be successful at that task. And then we can always change this. Let's change this to employee number 19. We get that probability for task B. And you'll see that 19, the probability of success is 18.69. Now, we are not in any way saying that, oh, just use this predictor and you're going to, all your worries will go away. Far from it, actually. This is simply just a starting point for you to build upon, because you need a lot of data points to ensure that this probability is valid. And what makes this probability valid is not only the history, but also the weights you're giving individual things. And we're going to get into that in a second, because what I would like to do is, we started creating it. I would like to pause in the creation of this and then bring you as the viewers and our fellow HR professionals back to actually create something like this for yourselves. And you're going to watch us do it here. That way you can see what is actually happening and why, to where you can build one for yourselves. And that's really what we want. We want to be able to empower you to take this, remove the fear on what machine learning is and what it means for our industry, and start using it to benefit yourself. And the other thing that we created was a heat map. And what this heat map is it's correlation between all of the factors that we use. We only currently have 9 factors, but this is the correlation. Blue is positive, high positive correlation, and dark red is high negative. Now, of course, current role tenure in years and current role tenure in years is always going to be a perfect correlation, because you're correlating it with itself. But what I would like to do also when we're building this inside a sheet is to just populate this in a tab so we can see the correlation between these that we have and adjust the weights as possible. Because high level, what machine learning does is it takes data, and a whole lot of data, depending on if it's deep learning or not. It takes data and then looks at the correlation of that and then formulates from that data a probability of an outcome. And that's really what we do in HR, except we don't look typically at all the data points, because we just simply don't have the time, the bandwidth, nor the ability really to. That's where machine learning can really come in and help us. Just as you can see, we can create this, the validity of this percentage, based on what we feed it and teach it. And that's what we're going to do here. We are building the framework so we can really start teaching this. And then once we have that framework done, we can create the competency or the career pathing through those competencies. And then all of this ties together to where we not only have an employee success predictor with a whole bunch of competencies for each employee and task, but also a career framework to where we can move individuals through successfully and sustainably in a data-based fashion. So let's go over and create a sheet. So I have a sheet already here created, and I populated it with a little bit of data. So our previous series, we created a randomized generator, and that's where this data is coming from. So you'll see we only have 9 data points here. So it's not very valid when it comes to it, because there's a lot of variables that we're not accounting for. Over the time, and once this starts evolving, we will try to capture every single one of those variables so we can get an actual accurate prediction. But for now, we're just using this to get it going. We have our current role tenure, current company tenure, average performance score, 0 to 5, certifications, our collaboration index. And what this is an employee is part of a project team or an initiative team. At the end of that initiative, each member kind of assigns a value based on rated criteria on that individual's ability to collaborate for a greater good, as opposed to just working individually. And then, of course, our training hours, peer feedback score, those 360s, and then if they got promoted in the last 3 years, and then their overall success. Now, as this evolves, this overall success will be assigned to each individual task. and each individual project. So we are going to capture essentially the entire employee's history. If you have an HRIS or you've been doing this for a few years, you should have a lot of this data. But you're also going to find that you have a lot of other variables that you're like, well, that isn't accounted for. It probably should be accounted for. So the data is going to be pretty robust eventually. So what the idea is to take all of these, assign them a weight of importance based on our company. So perhaps an indicator of success is a high feedback score, a high training hours, and average performance score. And then certifications, maybe these job titles don't have certifications, so these would be a lower weight. We don't want a person with 5 certifications that really have nothing to do with the role have a higher weight, because that's going to adjust that percentage. So it's going to come down to the weights and the variables that we have that make up this success label. Because what we're going to do is we're going to find the correlation between each one of these columns based on each other. And I would just like to create that matrix that we had in that HTML page and just maybe put it in another sheet here, just so you can see what it is that I'm talking about. So let's create ourselves a Google Apps Script. So let's go over here and we'll use Google Apps Scripts to do this. Now again, Apps Script is not designed to do what we're asking it to do right now. It's going to do it, but it's going to be very limited. And you'll see that once we start building this out, AppScript is not going to be able to run it. We're going to have to migrate it over to, we'll probably migrate it over to Python and then use a library to really find the correlation and the weights based on our data. And we'll use like, I don't know, skitlearning or something like that, whatever library it is we choose to use. But we'll take you along for that journey as well. So let's get this started in AppScript. Let's open up our AppScript file. And I called this Employee Success Predictor. Now what we're wanting to do is grab the data from that. And since we're going to populate it onto its own tab, we'll grab the data and then we'll grab the header. So let's get rid of this my function thing here. And we'll call this generate correlation matrix. This way we don't have to manually create it. Let's grab our sheet data. Now this isn't going to be an introduction to Google Apps Script. I think we've done a good job on a few other series, particularly beginning Apps Script for HR. So if you're interested in digging into Google Apps Script at a basic level, that would be a great series to watch. That way you can see what we're doing here. And this variable, in order to grab this data, we first need to grab our spreadsheet app, get our active spreadsheet, since this is bound to that spreadsheet. And then we want to get the active, no, we don't want to get the active sheet because we can just get the sheet by name. And that sheet by name is this tab name here, data. So we can go to get sheet by name, and that name is going to be data. So now we need to get the values of that. And let's just store that in a variable, and we'll call that variable data range, I guess. That'll work. And that's going to be the sheet. We want to get the range of this, and we could use get data range, but I would like to just go more in depth and use get range with the integers for rows and columns. So we want to start at row 2, column 1. And then we want to get the last row in the last column. So this is going to be 2, 1, sheet.get last row. And since we're starting at row 2, we're going to have to subtract 1 to take up that empty space at the bottom. when you pull your data, if you have an empty space at the bottom, you typically forgot the -1 because you got to erase that. And then we want to get the last row, not last row, excuse me, the last column. Like so. And then end it like that. Okay, good. And then we also want to get the headers. So let's get the headers. And we'll just call that variable headers, not herders, headers. And this is going to be equal to sheet get range 1, 1, 1, because we want to only include one row, and then we want to get the last column. Okay, so now we have those stored in a variable, we got to get the values. So what we can do is let's create a new variable and call it data, and that will be data range.get values. And then let's just store the values in our headers here. So we can do get values. And then what I want to do is I want to log these out because I want to show you we're going to have to do something different to these headers here. So we'll log out data. And then we'll log out headers. And we'll save it and then we'll run it and see what we got here. Okay, so let's see what we got. Get active spreadsheet.get sheet by name is not a function. Okay, so let's see what I was talking about here. Okay, see what I did there. It's not lowercase, camel case. Okay, so let's try that again. Okay, you may have to authorize it. If you do, just go through that. But you'll see that we have a two-dimensional array of all of our data in the form of numbers, which is good. That's what we need. You got to do math on numbers. And then we have our headers, and these headers come to us in a two-dimensional array. So the way that we're going to approach this is we are going to go through with a for loop and grab every single one of these elements and paste it to where it needs to be, because it's going to have a row, a top row, but then it's going to have that left column going down. So we need to grab these individually, and we'll do that with the for loop. But we can't do that. I mean, I guess we can. It'd just be easier to do that if it's in a one-dimensional array. And since this is a two-dimensional array with one array in between it, you see that right there, we can just grab that by selecting the 0 index. So now when we run it, you'll see that it is a one-dimensional array that we can just cycle through. Okay, good. So now what we need to do is create that tab where we're going to dump all this. And let's just store that in a variable and call it matrix tab. And this is going to be equal to spreadsheet app get active spreadsheet. And what we're going to do is we're going to want to insert a sheet. There we go, insert sheet. And that's a method, so now we need to call it something. So let's call this correlation matrix. And now what we're going to need to do in that correlation matrix sheet is set these headers. Set headers for correlation matrix. Okay, good. And this is where our for loop's going to come in. Now remember, we have to do our headers here up top, and then also down the side. So we're going to have to run a for loop to create the row, and then the for loop to create the X, or the Y, excuse me. So we want to do for, and we'll call that, let's just call it I. And we want I to equal 0. And we want this for loop to run for however long the header array is. So we don't want to give it a static number because we are definitely going to be adding on columns here. So we just want to have that picked up dynamically to find that length. And we can do this by running it until I is less than headers.length. And then we want to increment that upwards. So we use the double plus incrementer. And now we need to do two different things, one for the header and one for the column. So we want to take our matrix tab and we want to get the range. Now remember, this is cycling through. This is a loop. So we want to take the range is going to involve this I. And since we're going to do our row, we want it to be our row 1. And let's give ourselves a little bit of space in the column. Let's go over 2. So we will say I plus 2, whatever I is for that loop. And then we want to set the value. Now we're not setting multiple values, we're just doing one value. And that value is going to be whatever that header is at that particular I. And now we want to do the same exact thing for the column. So it's going to look similar, but slightly different. Instead of starting at row 1, we want to start at row I plus 2. And again, this 2 can be anything. It could just be any size. I'm adding 2 just so we can move it away from that left edge there. And then column 1. And then it's going to go down all the way. And then we want to set that value to whatever headers I is at that time. Okay, good. Good. So now what we need to do is calculate. We need to do some calculating stuff here. And I'll try to explain this. I'm going to try and find the balance. We've done correlation a lot in our previous series, and it takes a bit to explain the functions and drilling down. So if you really want to know the actual formula and how we're doing it, I suggest you go back and watch those other previous videos. But I'll try to explain it at a very high level, because essentially what we're going to do is create a function to fill in all the formula values and then create the formula to return. And I think we should put this in our, I think if we're going to need to find the correlation, we have the headers. That's good. If we need to find the correlation, I think we need to put it into our own little utility function. And what this formula is going to look like is, let's see if I can type it out here somewhat decently. Correlation formula. So what we're going to need our function to actually do is grab and populate these variables and then perform this formula. So our correlation is going to be R, and what R is going to be equal to is our little sum. Let's see how I'm going to be able to do this here in our code. Let me just grab this little sigma here, and instead we will just comment this all out. So what it's going to be is our little sum here. And we need to take the values of our x, so we'll do xi, and we're going to need to subtract the mean x. And then we're going to need to kind of do the same exact thing of yi minus mean y. And then this is going to be divided by the square root of our sigma xi minus mean x, and this is going to be squared. And then we need another one of those, and then we're going to do the same exact thing for yi and y mean 2. Okay, so that is our formula. So now what we're going to have to do is write a function to do just this. And that's what we're going to do. So let's create a utility function, because we're going to call this function quite a bit. And we'll call this, well, let's just say utility function to calculate a correlation between two arrays, because we have the horizontal array and the vertical array. So let's call this function, let's be incredibly original and just say calculate correlation. And anytime that we need to calculate the correlation, which we will quite a bit, especially when we're doing our predictions, we can just simply call this correlation here. And that is going to take two arguments in the form of an array. So we can just call this R1 and R2. Now, the first thing that we're going to need is the length of this, because if anytime we're going to find the mean, we got to find the length. So let's call that in. And since the array 1 and the array 2 are exactly the same length, at least they better be, they're that exactly the same length, we can just grab one. So let's just grab the x, which will be our array 1, and get the length. So now this array 1 doesn't exist yet, nor does this array 2. We're going to have to pass that. And we'll pass that with a for loop. So now we need to find these. So let's find those real quick. Let's call this let, and we'll just use that, mean 1. This is going to be equal to R1, and this in itself is a helper function. We'll use reduce to do this. So it'll be reduce, and reduce, and if you've watched our previous videos, we do this a lot to find our average. So this is a very handy code line to use. So it's going to take in A and B. We'll do an arrow function here. And what we're wanting to do is A plus B starting at 0. And then we want to divide this by n. And then that'll give us our average for our mean. And let's do the same exact thing for mean 2. And it's going to be the same exact thing as this. Should put that in there and change the 2. There we go. Okay, good. So now we have our averages. Now we need to find our covariance. And you'll see as we're writing this code where this is all fitting in. So we'll need to find our covariance and then our standard deviations of mean 1 and mean 2. And we'll just call this covariance. And we'll do that on R1. And we need to map this And what we're going to map is X and I. We'll do our arrow function. So every time we are mapping each one of these elements in here, we are going to want to run a calculation or a piece of code. And what that calculation is going to be is X minus mean 1 times ARR2 at I minus mean 2. And then what we're going to need to do is reduce this down using, we don't need the average or the number, but we do need this piece. And then we just simply reduce that down to find it. Okay, so let's make sure that that is actually what we're doing here. So X and I, and for every single I, finding this, which is that, and then we're multiplying it by our second array value at that I, and then we're subtracting the average of 2, and then we're reducing that down to a single number. Okay, good. So now we need to find the standard deviation of each one of them. So let's do stand dev 1, and this stand dev 1 is going to be the square root of this. So essentially it's the covariance of both standard deviations. This covariance has to be divided by both standard deviations. So what we need to do is find this. So this is actually what is going to be called, we're going to use math square root and math power. So the first thing we're going to need to do is math.square root, and we'll do our first array, and we need to map this. And what we're going to map is our X, but we can't just run straight X because we need to do, we need to do this piece. We need to raise it to the power first. So this is going to be math pow X minus mean 1 squared. And then we also want to reduce that down to a single number. Like so. And then in that line. And then what we want to do is let's grab this, because we need to do the same exact thing, except for our Y. So instead of it being R1, it'll be R2, that second array, and it won't be mean 1, it'll be mean 2, and then it'll reduce that down to a single number. Okay, good. So now we have all of the information placed in here and here. Now we just need to take our variance and divide it by both, or the product, I should say, of both these standard deviations. So that's what we're wanting to return. We're wanting to return the covariance variable divided by stddev1 times stddev2. Well, okay, good. So now we have our helper function. So now what we can do is take this helper function here and call it in a for loop to populate those correlation values. So let's do that up here. Let's calculate and populate the correlation values. Oops, this belongs in this function. My mistake. There we go. So this for loops ran, populated the matrix heading and the column in the row there. And now what we need to do is run another for loop, and let's just change it from I, we'll call it row. Row is going to be equal to 0 initially. And we want to go for however long our header's length is. And we want to increment that by upwards by 1, so that will be row plus plus. And what we're going to want to do is embed another for loop for the column. So this will be for let column equals 0. And the column length is going to be, or the column is going to run for however long the header's length is, just as above. And then we're going to want to take that and increment it upwards. So that'll be column plus plus. And for both of these, we want to take our correlation, call our correlation for each one of these elements, each one of those numbers inside that array. So what we're going to do is create a variable. We'll call this variable correlation. If I can spell it right, correlation. And we need to call our calculate correlation function, and we're going to have to call quite a bit. So what we're going to do is, instead of doing this in a series of lines, we'll just condense it and try and work through what happens operationally. The first thing we're going to need to do is get the column. So let's get our column at the data right here, and row. And then we also need to get the column at the data for call. This and this is what we need to take care of. Store that in a variable, and then we can take our matrix tab, get range, and we need to get the range at whatever row it is. Plus 2. The reason why we need to add 2 is because we don't have that header piece. And we moved it over, as well as the column plus 2. And then we can set the value. It's only going to be one value per cell. And the set value is going to simply be this correlation right here. And then it'll run on to the next one, and then the next one, and the next one, and so on, until it gets to whatever length of the header is. Okay, good, good, good. So now let's save this and make sure that we have something. Oops, line 19. Let's see what in the world we got going on here. So that's that. So let's see what this is talking about here. I think I know what I did here. So that's not a comma. Yep, there it is. Syntax is a semicolon, not a comma. Okay, so now let's save this again, see if it states, and then go back and kind of look at what we did in the flow of this. Okay, so always get into the habit of saving your code, because if you're writing a lot of code, didn't save it, there we go. If you're writing a lot of code and you lose internet connection, especially with Google AppScript, you can essentially lose everything that you just did. So get into a habit of code. And I think, let's make sure that this for loop, because we just wrote a lot of stuff. So we're taking care of our row data here. we're taking care of our column data here. And then what we're doing is we're storing our correlation in our variable by calling this calculate correlation function. And we need to call a separate, let me change this because I noticed that this get column kind of looks like that. So I'm going to change this. This is actually a function. I was running it through my head. This is actually just a function. So we'll say get, let's just change this to get column data because this is a separate function. And we're going to pass to that function the data and the row. And then we're also going to call that again and pass the data in the column. And then whatever that comes back as is stored in this correlation variable, and then it's populated here. So now let's create this helper function, and we'll call it a utility function, because that's kind of what it is, and that's probably where it's going to go. And what we need to do is grab our data at each one of these points. You grab each one of these. So what we're going to have to run inside this is we're going to need to extract essentially the column data, and it's going to be this in this two-dimensional array from the 2D array. So let's create this function, and that function is this. And we're obviously receiving data in row, and then we're calling that again, and then receiving data in column. So we got to call this a little bit different, because we're going to receive data, but we don't want to reference it to what it is. We don't want to confuse the thing, kind of like we changed our get column just because it's a little too close to that app script method. So what we can do is it's going to receive essentially two pieces of data. Let's call that first piece of data, not matrix. And then that second piece of data is essentially the index of what column this is. So we can just simply refer to that here as, let's just call it call index. And then what we can do is, since it's a two-dimensional array, if you think about the way two-dimensional arrays work, is each array itself is a row, and each element within those subarrays is a column. So what we're going to want to do is return from the matrix whatever value this column index is at that particular row, which that row is that inner array. So to do that, we can use our map method. And we will just refer to this as row. We'll use our arrow function here. And what we're wanting to get is the row or that inner index at whatever column index that is. So it's going to look like that. Okay, so that should take care of that. So now let's see what is supposed to happen here. So what's supposed to happen with this function is it's going to create, obviously, another sheet. It's going to give these headers across the top, headers down the side here. And then it's going to go through, and every single one of these versus one of these is going to find the correlation of them and create a matrix. Now that matrix is going to have a diagonal line. It should, anyway, if we did this correctly, should have a diagonal line of ones. So anytime that we have, like, say, promotion, the correlation between this promotion and, say, the promotion header over here should be +1. So we should have a diagonal line of 1, and then the others will be the correlation based on this data. So let's go ahead and run that and see if that's what we get. So we'll save it. Let's run it, see if there's any errors. Okay, execution complete. So now let's go back over here to our page, and you'll see that it created this, and now we have a matrix. Okay, good. Good, good, good. What we can do is just bold that. Okay, so now we have a correlation matrix table. And as you can see, obviously employee ID and employee ID is always 1. We're not too worried about this employee ID. We actually don't need this employee ID. So let's go ahead and change that real quick. Because the employee ID doesn't matter. It's just a number that it's an identifying number. So we don't actually need this piece here. So let's come back over here to our code. And instead of our data range up here starting at column 1, let's have it start at column 2, and that will take care of that employee ID number. And then down here for our headers, we don't want to include that header, so we'll put that at 2. Okay, so now let's run this again, and it should create another correlation matrix without those headers. Okay, good. Good, 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 good. Okay, not sure what that's about. I think that's about because of that, but okay, good. So now we have this. I'll figure out why it went over 1. I think it went over 1 because we added that other one. We can change that later, but anyway, we have now a correlation matrix. So now the idea with this correlation matrix, okay, we have it right here. So if you're following along and building your own, this is what you should have here. And if we're wanting to find an employee's, say, an employee's predicted probability, then that is where these correlations would actually come into play. Now, this is just based on our data here, our raw data. What we're going to need to do, and we'll end this video and then start another one, what we're going to need to do is actually create that HTML piece, but also we need to grab these and add weights to them, because that will change our overall probability and prediction there. So let's go ahead and I'm going to end this video here. And then in the next video, what we'll do is we will create, we'll just create that HTML piece real quick. And then we'll go in and do our HTML service to get it to work and get it to populate. And then what we'll do is we will create that employee prediction piece based on scales and coefficients, and actually build out that learning model. So I hope this has been informative. I know it was quite a bit and a lot, and you know, I know that maybe perhaps this correlation matrix doesn't make sense, but it will once we start getting into assigning weights and ranges and coefficients. So until next time, please take care, and I'll see you then.